Hello and welcome back to Revised Chemistry with Mr. B. In this video we're going to look at some more examples of the electrolysis of molten compounds. If you haven't seen my previous video, which is just electrolysis of molten compounds, watch that one first for an introduction to this topic. In an exam, if you get asked about the electrolysis of a molten compound such as magnesium chloride, the first thing to do is find a corner of your exam paper where you can sketch out the electrolysis cell. Make one side the positive and one side the negative, and then label the anode and the cathode. And if you're not sure which is which, remember panic, which stands for positive anode and negative is cathode. We then need to think about the liquid once we've melted the magnesium chloride, and we need to think about what ions that might contain. Well, magnesium is in group 2, so that will be formed from magnesium Mg2+ ions, and chlorine is in group 7, so chloride ions form 1- ions. If you're not sure about how to work out the charges on ions, follow the link that I've put up here at the moment. So we've got magnesium 2+ ions and chloride 1- ions. We must remember during electrolysis opposite charges attract. That means the magnesium ions are going to move towards the cathode because the ions are positive and the cathode is negative. So magnesium ions move over to the cathode, so magnesium is made at the cathode. Whereas at the anode, the chloride ions move over to the anode because once again opposite charges attract and chloride ions are negative, so they're going to go to the positive side. So we'd find chlorine being made at the anode. So this is a typical example of electrolysis. Remember, electrolysis means splitting up a compound using electricity. In this case, we're splitting up magnesium chloride into magnesium and chlorine. Let's look at another example, which is the electrolysis of molten lead bromide. So all we've got there is lead bromide, which has been melted. It needs to be in liquid form so the ions are free to move, so that some ions can go to the cathode and some ions can go to the anode, and it will conduct electricity. So once again, we do a quick sketch of the electrolysis cell, make one side the positive, one side the negative, label the anode and the cathode, and we need to think about what ions are in the liquid, the electrolyte. So in this case, lead is in that middle section, so if in doubt they make 2+ ions. Bromine is group 7, it's a halogen, they'll make 1- ions. And remember, opposite charges attract. That means the lead is going to go towards the negative cathode because the lead ions are positive, so at the cathode you would find lead being made. The bromide ions are negative, so they're going to be attracted towards the positive anode, so at the anode, bromine is made at the anode. So the rest of the video is strictly higher tier only. We're going to be talking about half equations, and when we start talking about oxidation and reduction in terms of half equations, that's for the top end of the higher tier students. So it is supposed to be challenging this, but stick with it. We'll see a few examples and we'll see how you get on. So in the first example, which was magnesium chloride, at the cathode we had magnesium ions moving over to the cathode and turning into magnesium atoms. Remember, during electrolysis we've always got ions changing into atoms. So there's going to be 2 electrons involved somewhere. Do we put them on the left or the right? In this case they go on the left so that the charge balances. On the left hand side of the arrow we've got 2+ and 2-, which is 0 charge, and on the right we've also got 0 charge. Now, if the question asks, is this oxidation or reduction, we need to remember the mnemonic: oxidation is loss, reduction is gain. Remember the phrase oil rig? So we're talking about the loss or gain of electrons. So in this example, you might be able to spot that the magnesium 2+ is gaining electrons. It's having them added on. So reduction is gain. So this is reduction because the Mg2+ is gaining electrons. If you can't spot that, the other method is using oxidation numbers. So that's essentially the charge. So the magnesium starts off as a +2, and then on the right hand side it's got 0 charge. So the number, the oxidation number, is reducing. It's going from +2 to 0. So if it's reducing, we call that reduction. On the anode side, we've got chloride ions changing into chlorine atoms. This time we need to put the electron on the right hand side. So we've got one negative charge on the left and one negative charge on the right. We must remember that chlorine goes round in pairs. It forms diatomic molecules because it's a halogen. So we need to double up in this case. So is it losing electrons or gaining electrons? Well, it's starting as a Cl-. We can see that negative charge, and it's ending up without any charge. So it's losing those negatives. It's losing electrons. And from the mnemonic, oxidation is loss of electrons. So if you can spot that it's losing electrons, you can see straight away it's oxidation. If you're struggling to spot it that way, we can go to oxidation numbers. And on the left, the Cl- is a -1. And then the Cl2 is 0. So in this case, the number is increasing. It's going from -1 to 0. And if the oxidation number is increasing, then we're seeing oxidation. Let's look at the second example, lead bromide. I'll put a link up at the top here to my previous video about oxidation and reduction in terms of electrons, in case you're struggling with that aspect. But look at, first of all, the half equation. So at the cathode, we've got lead ions changing into lead atoms. Remember, it's always ions changing into atoms. So in this case, we need 2 electrons. They need to go on the left so that we've got 0 charge altogether on the left with the 2+ and 2- and 0 charge on the right. Then we need to think about, is it oxidation or reduction? Oxidation is loss of electrons. Reduction is gain of electrons. Now in this case we can see we've got Pb2+ plus 2 electrons. It's gaining electrons, so that's reduction. Or we could think about the oxidation numbers. The Pb2+ is a +2 and the Pb is 0. So the number is reducing, so that's reduction. So we get the same answer using a different method. At the anode, we've got bromide ions changing into bromine atoms. So this time the electron goes on the right, so that we've got 1- on the left and 1- on the right. And bromine is also a halogen, so that will go round in pairs. So we need to double up. And this time it's losing electrons, so that is going to be oxidation. Oxidation is loss, if you remember oil rig. And if you can't spot it that way, we could go to oxidation numbers. We've got a -1 on the left because it's Br- and 0 on the right. So the number is getting higher. It's going from -1 to 0. It's increasing. So if the oxidation number is increasing, we say that is oxidation. Now there are a few rules you can remember. At the cathode, it's always going to be gaining electrons, so it's going to be reduction. At the anode, it's always going to be losing electrons, so that's oxidation. If you found the video useful, please remember to like and subscribe and share it on social media. Thank you for watching.